Question 13, part C, a big 9-mark mathematical induction question here. So for part C, it says use mathematical induction to prove, and this here, sine x plus sine 3x, so on, plus sine of 2n minus 1x will equal this expression here. Now n is an element of the positive integers. Okay, so it's proof by induction, so let's start with our expression, p of n, should be an n. This is our statement that this sine x plus sine of 3x plus so on, plus sine of 2n minus 1x will equal 1 minus cos 2nx over 2 sine x. Okay, so that's our statement. So we want to start with the first positive integer. So if n equals 1, p of 1 will be, so let's sub in 1 to this equation here. It's just going to be 1 minus cos of 2x over 2 sine x. And we know that this is actually equal to, from part B, we know that that's just equal to sine x. So that's equivalent to sine x. We know that from part B. From B. And if we sub in n equals 1 into the left-hand side here, well, sine of 2 times 1 minus 1 is just sine x. So this works. So we have proved this here. So this is true. Okay. After we've done the first one, we need to assume p of k is true. So assume p of k true. So therefore what we get is sine x plus sine 3x plus ... all the way to sine of 2k, and n is now k, minus 1x will equal 1 minus cos 2kx over 2 sine x. Extremely important here. We need to use the words assume and true. The mark scheme's always pretty strict on this. It needs to have assume and needs to have true. Okay, so once we assume that is true, we want to consider p of k plus 1. And the goal is if we can get p to k plus 1 to work, and then we can assume it's true for all of them. Okay. So let's go ahead and write, once we've assumed, so we're going to have p of k plus 1. This expression is essentially going to be the same as above, sine x plus sine 3x all the way to sine of 2k minus 1x, and then also plus sine of 2k plus 1 x, and we want to make that, or hopefully, equivalent to 1 minus cos 2, instead of n, or instead of k actually, it's going to be k plus 1 x all over 2 sine x. Now let's work with the left hand side here. Left hand side. Essentially what I have all the way to, from here all the way to here, to 2k minus 1 is x1. We know that that is essentially 1 minus cos 2kx over 2 sine x. And then if I add so plus sine 2k plus 1 x, I know that all of this was proven before. That's the assumption of the truth there for p of k. So I can sort of change my expression to all of this plus sine of 2k plus 1x. What I then want to do is I want to try and get a common denominator of 2 sine x. So I'm going to multiply this term here by 2 sine x top and bottom. So I'm going to have 1 minus cos of 2kx plus, And now I'm going to have 2 sine x, I'm timesing 2 sine x by top and bottom here, times sine of 2k plus 1 x all over our common denominator of 2 sine x. So to continue on here, this gets a little bit tricky here, so I'm just going to step this out. This is actually now 1 minus cos 2kx plus. I'm going to just briefly expand this. This might find it easier. So 2 sine x and then times sine of 2kx, and also 2kx and just plus x all over 2 sine x. What I'm going to have here is actually a formula I can use. It's the compound angle identity. Sine of an angle plus an angle is sine, the first one cos, and then cos and sine. So I'm going to apply that formula to this section here. So that's going to leave me with 1 minus cos 2kx plus 2 sine x. Now I'm going to the first bit. This will be sine 2kx cos the second one x, and then plus, I still have my 2 sine x, and I'll have sine of the second one x cos 2kx. So this is a bit of a long proof here. 2 sine x. Now what I can do is I can simplify this. 1 minus cos of 2kx plus 2 sine x and cos x I can simplify. So 2 sine x and cos x I can simplify using the double angle formula. So that's actually sine 2x. So sine 2x and then times sine of 2kx, and then plus sine x and sine x, I'll have 2 sine squared x cos of 2kx over 2 sine x. This top line again can be simplified, so it's going to be 1. Cos 2x is common in this term here and this term here, so I'm going to put a minus sign. This will get confusing, so it's minus and then a bracket, and I'm going to have another bracket here. I'm going to have 1, and it's going to be minus 2 sine squared x cos 2kx, because cos 2x times 1 is this one here, and it's minus, and cos 2kx times 2 sine squared x is this term here, and the minus turn it positive, and then we have this middle term which stays the same. That'll be minus sine 2x sine 2kx. That needs to be minus because the minus turns it positive, all over 2 sine x. We're getting there. Stay with me. So this is equal to 1 minus, we're going to have 1 minus 2 sine squared x, we know is double angle formula, cos 2x. This will just be cos 2x, and then we have cos 2kx, cos 2kx, and then we still have our minus sine of 2x, sine of 2kx over 2 sine x. Getting closer. We know that this is actually now the reverse of the compound angle formula, this one here, the cos formula. So if we apply that, we're going to get 1 minus, and this will be cos, and sines will be cos 2kx plus 2x. Yes, that's right. Over 2 sine x, which is also equal to 1 minus cos of 2 at the front of k plus 1 x over 2 sine x, and that's actually it. Oh, we managed to get there. Let's have a look at the top, and that's what we have here, down here. So to finish this off, so if true for n equals k, then also true for n equals k plus 1, and also as true for n equals 1, then it must be true for all values of n, for all values of n being the positive integers. Okay, that's the answer.